When a magnet or an electric charge or mass is brought close to another, it exerts a force. This ability of these bodies to sense another body in its vicinity and to exert a force whose magnitude and direction it somehow knows really perplexed people for centuries. In those days, they called this ability as action at a distance, till of course Michael Faraday came on the scene. Faraday explained this by saying that the very act of placing a magnet or an electric charge or a mass changes the surrounding space, and this altered space he named as the field. So a magnet creates a magnetic field, an electric charge has its electric field, and a mass is surrounded by its gravitational field. Okay, so there is something called as field. But can we see it? No, we can't. But we can visualize it. We can even sketch it using what are called as the lines of force. So a magnet has magnetic lines of force around it, and we can visualize them as the path followed by a small magnetic monopole left on its own. Now, magnetic monopole is just a north pole or just a south pole. It almost sounds mysterious, like a clap with one hand or a coin having one side. But high energy physics predicts it, and in theory we can still use it. So here is a magnetic monopole, a pure north pole, and it is kept in the vicinity of this bar magnet. So the south pole exerts an attractive force shown here in red, and the north pole exerts a repulsive force shown here in blue, and this green force is the resultant of the two. And of course, as the monopole moves around, these forces alter, and so does the resultant. And then using these we can trace the magnetic lines of force. Of course, you might have noticed that we can change the distance, but the forces are altering much faster, and that is because the force varies with inverse of the square of the distance. So if we halve the distance, the force actually quadruples. Of course, in real life we don't have a magnetic monopole, so we will have to follow a different procedure. Let's take a look at that. So here is our lab, or rather the simulation of the lab in MicroStation, and we have been given one bar magnet over here. These are the north and south poles, and we also have a small magnetic needle. A magnetic needle is nothing but a light magnet which we can move around the given magnet and plot the lines of forces. Some lines of forces are already plotted just to get an idea how they look, and now let us see how we can plot our own. So we take this magnetic needle and we start moving it around. So we are going to take it from here and place it on it at its own tip, and again we will take it and place at its own tip, and by doing so we can plot a magnetic line of force. To get an idea, let us see how this moves around the bar magnet. You can see the blue part, which is the south pole of the needle, gets attracted towards the north pole, and the red part, which is the north pole, gets attracted towards the south. By continuously moving this magnetic needle step by step, we can plot its various positions and then join them together to get a magnetic line of force.